Hi guys, this is Matt from DRT Racing, and today I have a very special video to bring you. We're going over the build process, first ride, and first dyno runs on my custom big bore YZ400 two-stroke that I've been spending the past 2 years developing, designing, and building. So stay tuned, because this is going to be a good one.
Hi guys, this is Matt. Welcome back to the shop, and I'm going to try to keep it quick today. We'll do a little update on what I've been up to. So over here we have the cases with all the bearings installed and everything ready to go. We're basically just waiting on the transmission and the cranks come back from Bryant Mototech. We have the cylinders all prepped and ready to go. They've been lapped. They've had the bores cleaned out real good with acetone. And the first one we'll be testing has the pipe manifold on it and the power valve installed. We also got the reed cage all assembled with the prototype reeds that we'll be testing. And everything's ready to go. Now, I can also give a quick update on what we plan on testing for the first round of everything. So my plan is to first obviously get the engine together and get the bike started and running and broken in. And I'm going to start off with the more conservative parts of all of the combinations available for right now. That just for safety and to see how it feels in its, quote unquote slowest form. So we have 3 cylinders to try, we have 3 heads to try. We have 2 different sets of reeds to try. We have crankcase stuffers versus no crankcase stuffers. We have 2 different 250 style pipes to try. Later on, we'll have a custom pipe made for this bike, but for now, we're going to start with the 250 pipes, and they have a corresponding exhaust manifold. We have 2 different carbs to try, but we're going to not mess with the second carb for now because the first carb I know will work well. We just have to get it tuned right, which will obviously take some time and effort. And then the ignition timing as well will vary with the different setups. We also have 2 different silencers. We have the stock one, which I'm going to take the restrictor out of the end of because according to my simulations, it's going to be too small with the restrictor in. And then I also have a R304 shorty to try. They're what I like on the 250s, either stock or an R304. So that's where we're starting with all that. Now I'll give a slightly more detailed description of what each of the different parts do. So the first cylinder is this one. This is the least aggressively ported one. It's only got a little bit changed from the stock MXZ cylinder. So the center port timing is changed from the MXZ. The intake port in the center here is significantly larger. Everything's cleaned up, and the sub exhaust ports are also opened up a little bit. Now, moving on to the next most aggressive cylinder, which is this one. Same mods as this one. However, we also significantly widened the center exhaust port. We went about as wide as the power valve will allow. And that's obviously going to increase power, but how much short circuiting we'll get from the transfer ports, not totally sure. So that's why this is the next step in that evolution, and we'll see if it's a benefit or a drawback. And then the last one, we also re-aimed the transfer ports a little bit more rearwards in addition to that center port being wider. So I think that'll give us a good combination of different variables to play with for the first go around. Obviously we can change it more down the road since we can kind of leapfrog each cylinder past each other if one's better than the other. Next up we have cylinder heads. I have 2 different compression ratios and 2 different chamber shapes. So I have two heads that are 14 to 1. I have one head that's 13 to 1. And then the two 14 to 1 heads, one is toroidal, one is not. They all have the same squish clearance. They all have the same squish band width. I'm just changing the chamber shape and the compression ratio for now. Obviously, again, we can change that more in the future. You know, I have a lathe over there that we can modify them on if needed, but and we could obviously make more too. The reeds, these are a custom set of Boyesen reeds. They have dual tensioners on them, so it's dual stage, dual tensioner, which allows them to change the stiffness of the pedals to try to get more bottom end without sacrificing top end, which is a nice change. And I have a second stiffness outer pedal to try if these ones are too stiff or not stiff. I can't remember which one's on it right now, but yeah. So two different sets of these. So that's good. Here are the crankcase stuffers. These will get pressed in the cases around the crank. They fill up some volume in the crankcase, and then obviously I can remove them if I want to increase the volume depending on what the bike likes more. They're made of a very gasoline resistant plastic called Ultem. It's kind of expensive, and it's also hard to print, so I had to outsource these. My printer couldn't do them, but they hopefully will work well and not dissolve and cause problems. But this is the most gasoline resistant 3D printable plastic available. So these will go in the cases. And let's see, for pipes, we have obviously the stock YZ400 pipe. We also have a DEP pipe down here on the shelf. I've had great success with both of those pipes on the 250s, and in simulation they look promising for the 400 as well. And obviously ignition timing you can change with the stator. Eventually I would like to get a programmable unit because the stock YZ advanced curve isn't the most ideal, but it'll work. A few more updates for today. We got the reed cage all put together finally with the manifold and the backing plate for it. Brian Lambert at Mototech plasma cut that backing plate for me. It came out really nice, so thank you, Brian. We'll be going over more of what he did for me in a little bit, but he's a huge part of this project, and definitely if you have a YZ, hit up Brian because he does great work. But everything fits pretty nice. I'm very happy with how the carb interacts with the cylinder. Nothing's hitting anything, which is awesome. So all my hard work on that one paid off, which is great. The next thing that I want to talk about are these case stuffers. I've gotten a lot of questions on what they are, why I need them, and what they do. Basically, on a two-stroke, the crankcase acts like a pump that forces air into the cylinder and also sucks air through the carb. So the carb feeds the crankcase, and the crankcase feeds the cylinder. And as a result of that, the volume of the crankcase is the effective compression ratio of the pump. Now, depending on different schools of thought, over time, the crankcase having a higher compression ratio versus a lower compression ratio is beneficial. Obviously, the higher the compression ratio, the more the crankcase will act like a pump. However, you then have a smaller volume to pull from into the cylinder, which more modern two-stroke tuning theory emphasizes more of the suction action of the pipe filling the cylinder and less of the pumping action of the crankcase filling the cylinder. And so generally nowadays people go for lower compression ratios for the crankcase. However, most of the modern theory has been centered around 125 cc GP engines, and this being a very large displacement engine, I think that the smaller volume may actually be beneficial. In simulation, the smaller crankcase volume ended up gaining about 2 horsepower over unstuffed. So having these stuffers allows me to vary that ratio without having to significantly machine or redesign the cases, which is awesome. Now, the only drawback is they're kind of a pain in the ass to make work correctly. I was originally going to just have them press fit into the cases. These are 3D printed out of plastic. And they do press fit quite nicely. The only issue is I was also planning on having them compress against each other when the cases are assembled. The only issue is getting them to do it just right. I don't really trust it, and I don't want them to move at all when the engine's running and vibrating and heated up. So I had to add the set screw or countersunk screw to make sure that they're not going to move around. And unfortunately, I had already installed all the bearings before I decided that was necessary, so I had to tape everything off, and it was very, very stressful, and it got my OCD very triggered. So here we're about to do the second one. You can see roughly the setup that I'm going to be using to do it, and I'm going to do it off camera just because it's kind of a pain, but that's what I've been up to for the past 2 days, and we're excited to start getting it fully put together. I also want to give a huge shout out to Brian at Mototech. He did a great job for me on a bunch of different stuff. First off, he assembled my crank for me. This crank was machined. It's completely custom crank, machined by Stamoly Precision in Pennsylvania. They did a great job. And the rod is off of a Sea-Doo 951, I believe. I'd have to check my notes on that, but fully custom crank with a different rod. This rod, I liked the length of it. It fit the engine nicely. And Brian did a fantastic job on this. As you could also see, it's not unboxed yet, but these circles here are tungsten counterweights, which I designed it around a 58% balance factor, and Brian machined those and installed them and got everything perfect. So very happy with that. Brian also did a full inspection of this gear set for me. These were not new gears. These are out of a friend's bike, and thankfully they were in great shape. He micro polished them all, and hopefully that's going to help this thing shift super smooth. And also the polishing process removes any stress risers from the gears, so any additional stress they're under from the increased power is going to be hopefully less likely to damage them because of the polishing process. So thanks again, Brian. These are all inspected, good to go. These two gears are custom. These were made by Gear and Repair out of Chicago area. They worked with Stamoly to come up with the center spline pattern and make it fit real nice. This spline pattern, I actually spent the better part of 2 days researching how to properly specify a spline pattern, and we mimicked the CR500 spline pattern actually, but they came out very well. The reason these are necessary is because, as mentioned in previous videos, the primary reduction between the crank and the clutch is increased on this bike to gear it essentially taller. This will take torque out of the gearbox. It'll make the gearbox spin faster but have less torque on it, which is a good thing because this bike's making a lot more torque than the stock one, and the bearings are rated for a higher speed anyway, so this is a pretty effective way of ensuring transmission longevity on a application they weren't originally designed for. And then because this gear was bigger, I also had to make the water pump gear bigger, which also isn't a bad thing because that's going to overdrive the water pump a little bit and increase the flow of coolant. I've had a couple people ask about cavitation. I'm not very worried about cavitation on this setup. The YZ impeller is a very efficient design, and there's nothing really wrong with it. And the worst case scenario, I've talked with Boyesen. They agree with me. They design water pumps as well, and they have a super cooler that I could add later on if I deem it's necessary. But for now, this is what we're going to run with, and we're super happy. So as of now, we have all the parts we need to put this together that I am aware of, unless there's something I missed and I'm gonna have to make a last minute McMaster order, but I think we're good to go, and we're gonna be forging ahead on putting this together over the next few days. So have a few more updates today on the YZ400 engine. First off, I got the gearbox installed, and I had put the other half on and assembled the gear mechanism to make sure everything shifts okay, and it shifts amazing. Brian Lambert at Mototech micro-polished these gears, and that paired with the tolerancing on the billet cases, and it's some of the snappiest shifting I've ever seen. We also got the crank installed. The crank was also done by Brian. I'll flip it around in a second and show you more. But we got that installed. I had to make this tool here. It's just an aluminum ring, because normally I would install the crank with a torch on the bearings so that it would just drop right in, because it is a press fit. However, this engine has plastic case stuffers that I didn't want to mess up with the torch. So what I did is I made this ring here so that when I use my crank puller, it only is pulling on the inner race of the bearing and isn't going to side load that bearing during installation, which is bad for it. So I can take this off. This is my crank puller. This comes off. And then I have this little aluminum ring I made on the lathe last night. That looks great. I also covered the splines of the crank output shaft with electrical tape. The purpose of the tape was to guide the aluminum ring so it wouldn't catch on this lip here as I was pulling through. But I'll leave the tape on because it'll end up being helpful later. While I'm putting the crank seal in, which this aluminum ring will also act as a nice seal driver potentially. If not, I have more aluminum to make more parts. But this came out nicely. Looks very nice. Now we can flip it around and I'll show you all of Brian's nice handiwork. As you can see, I have a very nice 2x4 engine stand. Don't sleep on it, it works really well, so no hating allowed. Also works good at keeping metal shavings away from the work area. Here we are. Yeah, so that came out great. Brian did a really nice job on it, and we're super excited piecing this all together. All right, the bike's all together and it's ready to start for the first time. Got the bike started up, took
Took about 5 kicks to start for the first time. The carb settings right now are a complete guess, but it idles really well. I barely had to adjust the idle screw at all, which means that I got a pretty good first guess on the jetting. Obviously we need to mess with the jetting or tuning because it's Lectron a little bit more before we take it on its first real ride, which we'll do that around the yard tomorrow. We'll probably mess with the ignition timing a little bit too, since I have it all marked out for each 2-degree increment. And we'll get it to a spot where it's good to ride at a real track, and we'll see how she does.
Hi guys, it's Matt at DRT. We're here at the track today testing the new YZ400. This will be the first real test ride. We're at Central Virginia Trail Riders Club that my family's a member of, and we have a little bit of track and a little bit of trail at our disposal for today. Spent all day yesterday getting the carb tuned in the yard and just working out a little bit of teething problems, but we're ready to go for today, and look forward to seeing how it runs.
Power seat the front yard, just come over for a day.
Yeah, it's just like,
oh man, that was a nice wheelie.
Thank you. So my first impressions on the bike. First off, it feels really well put together. I've ridden a lot of project bikes over the years of varying degrees of difficulty and complexity, and this bike just feels very tight, very factory fresh, and no weird quirks or anything. It feels like a new bike that's ready to be ridden, which is awesome, considering how much time and effort I put into it over the past few years. The next impression I have is that it's very fast but very manageable. The conditions here today are super slick. There's a lot of slimy mud, kind of greasy on top, and on any bike it would be hard to put the power down, but this bike puts the power down really well. It has a heavy crank, and it puts the energy that the engine's creating into the dirt really well, even when the wheel's spinning. I don't think I've ever ridden a bike where it feels like it's accelerating as fast as it is while also spinning at the same time. The amount of drive you have, even with limited traction, is really cool. It's also very fast. In this state of tune, which is its slowest state of tune, it's still a little bit faster than a stock 450, a modern stock 450, and it's very fast on top, but very smooth on the bottom, and has really good partial throttle roll-on response, which is something that some two-strokes struggle with. This does great. Very, very easy to put the power down, but as soon as you keep your wrist in it, it starts getting really fast, really quick. Next impression is that the gearing is a little bit tall, but it has plenty of torque to pull the gearing. It has no problem carrying tall gears around turns and getting going really quick. It's super light and nimble. The additional rotating mass didn't really affect the handling negatively at all, nor did it affect the overall weight of the bike. It actually weighs almost exactly the same as a stock 250, and you can tell it's very nimble, very light, and flicks around. You can change direction just as well as on a 250 on it. The last impression I have is something that we're going to work on moving forward a little bit. It has a little bit of a dip in the mid-range currently. Some of you might notice that I'm clutching out of the turns a tiny bit. This dip in the mid-range is from the power valve not being fully dialed in yet, and we'll see a little bit more of that on the dyno. But we have a very good idea of what we want to do moving forward to fix this. We just have to spend some time addressing it. But overall, for a first ride on a brand new, never been ridden before bike, this thing rips. Alright, so it's the next day, and we went straight from the track to my good friend Pete Payne at Heavy Duty Racing shop, and we're going to get some dyno numbers on this thing. Today we're just going to be testing the 3 different heads I've designed, starting with the one from the track, which was the lowest compression one. We have 2 higher compression ones that are slightly different, and we're going to see how they all stack up against each other. For each head, we're going to redial in the carb and the ignition timing to make sure that we're getting the best results from each one, and we're going to see how they compare to each other. And then from here, we're going to do some more testing in the future on different cylinders and pipes and reeds, but for today, we're just going to do heads.
right, so here are the results for the 3 different heads we tested. You'll see the head we started with at the track yesterday is the yellow line. That one's the lowest compression and least aggressive one. And it was making about 56 horsepower at the rear wheel. Now, a little disclaimer, these numbers are all rear wheel horsepower numbers. A lot of the numbers you're used to seeing in magazines and such are at the crank. So, generally, rule of thumb is add about 12% to these numbers and you'll get the numbers you're used to seeing. So, before you think, oh man, that's only 60 horsepower, 60 horsepower at the rear wheel is pretty significant. So, back to the heads. The yellow head was the original one. Then the red line is the higher compression one, but it has a toroidal combustion chamber design. These are really popular in GP bikes and smaller displacement engines. Some people use them in bigger stuff too, but in this case, it ended up losing to the more hemispheric combustion chamber of the other head, which is the green line, which is the same compression ratio, same squish band dimensions. Everything's the same other than the shape of the actual chamber itself. So we ended up gaining a fair amount more horsepower with that one than the other one, and we're pretty happy with where we're at so far. So for each of these heads, we did try going richer and leaner with both the torque jet and power jet on the Lectron, just to make sure that the different heads didn't require different fueling demands. Turns out these all liked pretty much the same settings. We definitely could have gone a tiny bit leaner on the least aggressive head. And it didn't make a ton of difference, but the end settings for like the best results for each ended up being essentially the same. We also did it with ignition timing. Right now, I have the stock YZ400 ignition box in it with the stator plate advanced as far as it'll go, which in this case is 6 degrees. We tried backing the timing off just to see if it liked that better, and all 3 heads liked the timing maxed out at 6 degrees from where it normally is. We do plan on getting a programmable ignition box in the future so we could better optimize this ignition curve. I would expect another 1 to 2 horsepower from more optimized ignition. And we have a bunch of other parts to test as well. All in, Pete and I both agree that there's probably another 10 more wheel horsepower in this engine waiting to be untapped. Between a fully developed pipe for this bike is going to be the biggest gain. We're expecting about 5 horsepower gain from that. We're also expecting another 3-ish horsepower from our more aggressively ported cylinders that I did. This one is the mildest of the 3. So between that, the ignition box, and the pipe, and some more fine tuning here and there, and we're pretty sure we can get to 70 at the rear wheel, which I think would be fantastic. The other things I'd like to point out is my goal was to make peak horsepower at 8,500 RPM, and I hit the nail on the head right there. I couldn't have asked for a better result. The peak power is exactly at 8,500 RPM, which goes to show how awesome simulation software is. It pretty much predicted exactly where we're going to be with this setup, and if the remaining setups with different combinations of parts continue to follow that trend, we definitely are going to hit 70 wheel horsepower, which is awesome. The last thing that I'd like to point out is, as mentioned in the riding section of the video, there is a little bit of a dip around 5,500 to 6,000 RPM. Now, this is because the power valve is opening too early. The setup on this is a pneumatic power valve. It uses the exhaust pressure to open it. And right now, the spring that holds it closed is just a little bit too weak. We have some more springs in the mail. We have to do some more testing, but we fully expect that dip to be closed up, and we'll have a very nice linear, strong engine at all RPMs. And obviously, that's going to get rid of any need to use the clutch out of turns unless you really want to. And
and we're really impressed with how this engine did just straight off the bat. All right, here's the chart I know you all have been waiting for. How does it compare to other bikes? Now, again, a disclaimer. First off, this is wheel horsepower, not crank horsepower. So don't get that confused. Also, I am aware that these bikes were not tested on the same day as my bike. The weather the day that I tested was actually pretty bad. So if anything, that would make my bike do better compared to these bikes if the weather were the same. And I'm aware that that's not the best way of doing testing, but they were the most recent comparisons Pete had in his data bank. So bear with me on that. Comparisons are just comparisons at the end of the day, and this is here for reference. By the time we're done with testing, the bike's going to have a lot more power, and it's not even going to be a comparison. So if you have anything negative to say about that, you can keep it to yourself. Now, the blue line here at 61 horsepower is my bike on its best run of the day. The green line is a current generation 450 motocross bike. As you can see, that bike makes about 55 horsepower. Mine makes 61, which I think is a pretty good starting point for this bike, considering it's only going to get better from here. You can also see that minus the dip in the mid-range, it's pretty strong across the board compared to the 450, and it's actually a pretty similar power curve as well. Obviously the 450 revs out a little bit better past peak, but up to peak, the power curves aren't that dissimilar, which definitely reflects in the way the bike rides on track. Like it doesn't do anything unpredictable really. It's somewhat four-stroke like in the way it puts the power down, just a little bit snappier and a little bit faster. Now the blue line is a well-built 252 stroke. So that bike I believe was a 01 CR250 with some headwork, a pipe, Lectron, and reeds. I'm pretty sure. Pete didn't build that bike; he dynoed it for a friend, so he's not 100% sure how it was set up. But it was a very strong running, well-built CR250, and that's basically what you would expect to see out of a strong running 252 stroke with all the basic mods at 45 horsepower. So we're up 15, 16 horsepower over a nicely built 252 stroke, and we're up about 6 horsepower over a modern fuel injected 450. So again, it's only going to get better from here. We're really impressed with this as its first day on the dyno. This bike was not even finished yet 3 days before these dyno runs. So again, as far as a really good start, I could not be happier with how this bike is doing, and I'm really excited to see where it goes from here. All right, well that does it for this video. I'd really like to thank everyone who's followed along this build from the beginning, and I definitely want to give a huge shout out to all the companies who helped along the way. Lectron Fuel Systems, Mototech, Retrodyne, Heavy Duty Racing, Cometic Gaskets, Klotz Lubricants, Stamoly Precision, Wayne Cycle Shop, Boyesen, Millenium Technologies, and Vannik Developments. I cannot express enough gratitude for how much you guys have helped along the way and how much of a blessing you guys are. These companies are the lifeblood of the industry, and they do everything to help their customers and other people like me who just want to build cool stuff and show it to the world. So thank you so much, guys. I really do appreciate it, and please subscribe for more.